Guys, you are able to see screen.
Yeah, I can see your screen.
Yeah. Today, do you have any questions on previous session, which we have
No,
discussed on the futures of Snowflake?
no. But my question is, am I going to be the only one in this session?
No. There are other people also. Don't worry about that.
Okay.
Today we will discuss about the Snowflake architecture. Okay. Yeah. So in Snowflake architecture, we have 3 layers. So one is database storage layer, and another one is query processing layer, and another one is cloud services layer. So we'll discuss one by one. So this is very much important. So you need to understand very well. Okay. Let me know in between if you get any doubts. Database storage layer is whenever we load the data into the Snowflake, the data will be stored. Data will be stored in a database storage layer only. Data will be stored in a database storage layer only. How the data is going to store? How the data is going to store in a Snowflake? Whenever we load the data into the Snowflake tables means the data is going to store in a Snowflake in form of a micro partitions. Micro partition is one of the storage. Micro partition is storage component in the Snowflake. Storage component in the Snowflake where we load the data into the tables, the data automatically store into the micro partitions. I will show you all these things, don't worry. And each micro partition size will be 500 MB. The combination of multiple, if you store the data into the table, the data will be resides into the combination of multiple micro partitions. Each micro partition size will be 500 MB, and the data will be stored in a Snowflake in a column format, not into traditional format, in a column format. Okay. One second, I will show you. Yeah. So let's assume we have a table T1. If you load the data into the table T1, by seeing the data will be, we can see into the traditional format only. That is nothing but the combination of columns and rows. And whenever you load the data into the table, the data will be stored into the multiple micro partitions. See, micro partition 1, micro partition 2, micro partition 3, and then micro partition 4. So each micro partition size will be 500 MB. Once the first micro partition is completed, then again it is started to save the data into the second micro partitions. Once the second is completed, and it is going to start load into the micro partition 3, and then 4, and then 5, etc. Okay, completely it's based on the size. Now what will happen? Whenever you load the data into the table must be occupied the number of micro partitions based on the data value. So this each and every information for which table, how many micro partitions are allocated, what are the micro partition number, all these system details will be return into the somewhere in the metadata table, somewhere in the metadata tables. See, while querying or retrieving a data, this metadata table will be very much helpful, because that optimizer while retrieving a data from the Snowflake, that optimizer need to understand in which micro partitions this table related data will be available. Then only it will go into the particular micro partitions and then bring the data. See, if the data or metadata is not available in the somewhere in the metadata tables, then it is difficult to the optimizer to bring the data, because there will be n number of tables in the Snowflake. For those tables, n number of micro partitions will be allocated. N number of micro partitions are allocated to bring the data for you from the particular table. It is going to use the metadata information and then bring the data. So in this case, instead of scanning all the micro partitions, it is going to scan only required number of micro partitions by using the metadata information. So by doing this, we can save the time and then we can see the performance improvement. Next thing is data. Data is going to store in form of a column format. See here, column name is type, column name is name, column name is country, column name is date. This is going to store in a column format: type, name, country, date. Type, name, country, date. Instead of storing a data in the combination of columns and rows, it is going to store in a column format. See here, type, name, country, date. The first value 2A UK and then 11 bar 2. 2A UK and then 11 bar 2. Data is stored in a column format. So what is the advantage? What is the advantage to stay? What is the advantage to save the data in a column format? Means while retrieving a data, see here, while retrieving a data from the micro partitions, as the data is stored in a column format. Suppose let's consider if you want to bring the first record, the data is available in the first micro partition. Micro partition. It is going to scan only one micro partition instead of other micro partitions, because the record is available in the one micro partition only. If the data is stored in form of a regular format, column into rows, the data may be split into the multiple micro partitions. To bring the one record itself, it needs to scan the multiple micro partitions if the data is available in a traditional format. Now the data is available in the column format. If you want to bring the particular record, then it is going to scan only the required number of micro partitions. Suppose if you want to bring the data select star from T1 where name equal to Y, the Y is available in the micro partition 3 and then micro partition 4. It is going to scan only these two. Only it is going to write these two micro partitions. It is going to scan these two micro partitions and then bring the data, because in the metadata information, it is going to write in which micro partitions what data is available. So by doing that, with the help of the micro partition, with the help of the metadata table, it is going to scan the only required number of micro partitions. Here, where name equal to Y means Y is available in the micro partition 3 and micro partition 4. Micro partition 3 and then micro partition 4. Then it is going to scan only two micro partitions and then bring the data from the table. instead of scanning those all micro partitions, it is going to scan only required number of micro partitions. By doing this, we see the performance improvement, right? While reading the data, you no need to write. Suppose if the optimizer is going to scan all the micro partitions to bring the particular request means, then it is killing the performance of your SQL. That's what in the previous session I said that you no need to apply any performance tuning techniques. Automatically, your Snowflake will be taken care. So these are the things how the data is going to store in the Snowflake, how the data is going to read in the Snowflakes. They have designed the architecture in such a way that automatically it will improve. One second, guys.
Sure.
So so that is what we see the very good performance improvement by using this storage layer architecture. One more thing is, see that data is scattered, data is split into the multiple micro partitions. Now we have one more beautiful concept in the Snowflake. You can create the cluster key on your table. You can create the cluster key on your table. If you create the cluster key on any particular column, the data will be stored in a sorting format. The data will be sorted in ascending order. See, data will be sorting in ascending order. Suppose if you create a clustering key on top of name column, the data is going to store in a ascending order. See, A, B, C, X, Y, Z. Now, if you write a query, select star from table where name equal to Y, earlier the Y value was available in the micro partition 3 and then micro partition 4. Now the value, both the Y's are available in the micro partition 4. It is going to scan only a one micro partition and then bring the data for you guys. So by doing that, so you can save the execution time of your SQL. So like this is the database storage architecture layer. How the data is going to store, how the data is going to read, from the Snowflake storage layer. Clear?
Yeah, clear.
Yeah. Next, so we have a query processing layer. Next layer is a query processing layer. So this is all about the compute resources. In previous session, I mentioned that compute resources means virtual warehouse. So this is a purely hardware resource to your Snowflake account. So without the virtual warehouse, you can't execute any SQLs. This is compute resource. This is compute resource. And then compute resources means I mentioned the hardware resources, which is in form of a virtual warehouse. This virtual warehouse itself one of the object in the Snowflake. You can create how you are creating table, database, and all. Like that, you can create this virtual warehouse with the create statement. But while creating this virtual warehouse, you can select the different sizes of this virtual warehouse. Okay, this is the
Okay.
these are the different virtual warehouse size: X small, medium, large, X large, etc. So these are the different sizes of your virtual warehouse size. While creating your virtual warehouse, you are going to select one of the virtual warehouse size according to the requirement. So here the beauty is you can create the multiple virtual warehouses and assign to the multiple projects to avoid the performance issues, because you are working for the one project and you are using your own independent virtual warehouse. So there is no shade this hardware resource to the across the projects. The virtual warehouses are project specific. If you are using your own project related virtual warehouse, then you are going to see the very good performance. You are going to see the very good performance improvement in all the activities. So there is no dependency between the one project to another project. There is no dependency on one virtual warehouse to the multiple projects. No, this virtual warehouse is not shared across to the multiple teams. Okay.
Yeah. Correct.
Yeah. So here is based on the utilization of your virtual warehouse. Suppose let's take X. If you have created a one virtual warehouse with the X small size, based on the utilization, it is going to generate the 1 credit per hour, and based on this credit only, the pricing will be happened. Okay,
Yeah. Correct.
clear or not clear?
Clear.
Yeah. Next, we have a cloud service layer. This is the topmost layer in the Snowflake, because without this cloud service layer, Snowflake account will not work, because like whenever you log in into the Snowflake account, authentication details will be checked by the Snowflake account only. That is nothing but whenever you log in into the Snowflake account, the username and then password will be checked. The username and password will be checked by the Snowflake account. Okay. See, I am a Shekhar and then I am a user of the Snowflake account. I am trying to log in into the Snowflake account. This authentication details cross verified by this cloud service layer only. If the user is valid user and is providing his credentials valid details, this cloud service layer will be verified before logging. If the user is valid, then only it will allow you to log in into the Snowflake account. It will allow you to log in into the Snowflake account. So that is one point. Second point is whenever the user is submitting SQL query to retrieve the data from the Snowflake account, the very first layer is cloud service layer accept that query. Okay, and the optimizer will cross verify your select statement or SQL query, and optimizer will cross verify whether the provided SQL is syntactically correct or not. It will cross verify in the very initial stage. Once your SQL query is valid, then it will pass that request to the query processing layer, and then you have a cache memory in the query processing layer. In this cache memory, you will be having a recently executed results. If the result is available for the query, and then it will return the data from optimizer will return the data from this query processing layer to the cloud service layer. If the results are not available in the cache memory, then the request will go into the database storage layer where the actual data is available. So from this database storage layer, the data will be written into the cloud service layer. This will be written into the end user. So this is another thing. So like that, it is going to take care about. It is going to manage your multiple warehouses. It is going to manage your transactions, and also it is going to manage your metadata tables. It is also going to take care about the security, everything. So that's why That's why this cloud service layer is important. Okay, Kumar, this is all about architecture. I am going to share all these details with you today by email.
Okay.
Once go through all these things, we will connect by tomorrow. Okay.
Okay. Got it.
Yeah. Thank you, Kumar. Bye.
Thank you too. Thank you too. Appreciate it. Yeah.